Alrighty, we're going to go ahead and get started with the Unit 6 Section 2 notes. In this section, we're going to be talking about greatest common factor. This is something you probably have done before, but we are going to just build on the knowledge that you already have. So a common factor between two numbers is a whole number that's a factor of two or more of those whole numbers. So it's a whole number that is a factor of two or more whole numbers. Okay, the greatest common factor is just the greatest of those common factors. Oftentimes you will see this abbreviated GCF. So if you ever see find the GCF, it's talking about the greatest common factor. So let's go ahead and try that. We're going to find the greatest common factor, or GCF, of 8 and 24. To start, I'm going to go ahead and write all of the factors of 8. So I know the factors of 8 are 1, 2, 4, and 8. I'm going to do the same thing with 24. So the factors of 24 would be 1, 2, 3, 4, 6, 8, 12, and 24. The greatest number that 8 and 24 share as a factor is in fact 8. So we would say our GCF, or greatest common factor, is equal to 8. Okay. We're going to try the same thing, but with 22 and 55. So the factors of 22 would be 1, 2, 11, and 22. We're going to do the same thing for 55. The factors of 55 would be 1, 5, 11, and 55. The greatest number that, or the greatest factor that these numbers share is 11. So here our GCF is equal to 11. All right, you can also find the greatest common factor for 3 numbers, and you do it the exact same way. So we'll list the factors for 16. They are 1, 2, 4, 8, and 16. We're going to do it for 32. Those factors are 1, 2, 4, 8, 16, and 32. We're also going to do it for 40. Last but not least, those factors are 1, 2, 4, 5, 8, 10, 20, and 40. The greatest factor that these numbers share is also 8. 16 and 32 both share the common factor of 16, but 16 is not a factor of 40, so the GCF is still 8. All right, I'm going to let you try number 4, again doing the same process with 27, 45, and 90. Be careful that your greatest common factor is a factor of all 3 numbers. Alrighty, we're going to move right along and talk about numbers that are relatively prime. In section 1, we talked about prime numbers having factors of itself and 1, those being the only 2 factors. That number is prime. If a number is relatively prime, all that means is that the greatest common factor that 2 numbers share, that GCF is 1. So if 2 numbers share a GCF of 1, that means they are relatively prime. So let's go ahead and look at the first example of 24 and 33. Again, I'm going to start by listing my factors of 24. They are 1, 2, 3, 4, 6, 8, 12, and 24. I'm then going to list my factors of 33. 1, 3. Well, we know that 24 and 33 share a common factor of 3, which is greater than 1. So we automatically know that these two numbers are not relatively prime. If we look at this example, 22, let's list the factors there. We've got 1, 2, 11, and 22. Again, we'll also list the factors of 35. We've got 1, 5, 7, and 35. The only factor that they share is 1, so they share a greatest common factor of 1, which means they are relatively prime. All right, friends, we're going to move right along and find the greatest common factor of monomials. The way that we do this is for our first one, we have two monomials, 32xy as well as 20y squared. So what we're going to do first is we are going to find the prime factorization of 32. So if you remember, we're going to start with 32 and we're going to do a factor tree to find that prime factorization. 32 can be broken down into 4 and 8. 4 can be broken down into 2 times 2. 8 can still be broken down into 2 and 4. And then finally that 4 can be broken down into 2 and 2. So the prime factorization of 32 would be 2 to the 5th power. And then we have x as a factor and y as a factor. If we do the same thing for 20, let's do the factor tree. We can break 20 down into 4 and 5. 4 can be broken down into 2 and 2. All of those numbers are prime, so we end there. So the prime factorization of 20 would be 2 squared times 5 times y times y. Now, in order to find the greatest common factor of these two monomials, we are going to see what factors they have in common. So first, we're going to look at our 2's. Right? We need to make sure that it is a shared factor. So 32 has 2 to the 5th and 20 has 2 squared. The highest that they both share is 2 squared. Now we need to see if both terms share an x. 32 has an x, but there is no x here. So x would not be part of the greatest common factor. Same thing with 5. There's a 5 here, but there's not a 5 here, so they do not share a common factor of 5. With y, there's 1y here, 2y here, but they only both have 1y. So I'm going to go ahead and add that there. So if we simplify this even further, the greatest common factor of these two monomials would be 4y. All right, I'm going to go do another example because I realize this is new and we may need to do several examples together. So let's go ahead and start with 33pq. So again, we're going to start with the prime factorization of the number 33. 33 can be broken down into 3 and 11. 3 and 11 are both prime numbers, so we stop there. So that factored would be 3 times 11 times p times q. We're going to do the same thing for 55. We're going to break 55 down into 5 and 11. Both of those are prime, so we can't go any further. So those factors would be 5 times 11 times p times q times q. Now again, we want to find the greatest shared factor between these two monomials. So they don't share a 3, they don't share a 5, they do share an 11. So that's going to be the first part of this greatest common factor. They both share p, however, there's 1 p here and 2 p's here. So for the shared factor, we're going to have 1 p, and same thing with q. There's 1 q here, 2 here. However, they both don't have 2. They both only have at least 1. So the greatest common factor of this monomial would be 11pq. All right, so we're going to do the same thing with number 3. I want you to notice carefully here that you have 3 different monomials here. The first one would be 12rst cubed. The second one would be 42r squared s cubed t squared. And the last one would be r times t to the 5th power. So we know that our greatest common factor have to be factors that all 3 monomials share. Because there are no numbers here in our last monomial, we know that we're not going to have numbers in our greatest common factor. So let's go ahead and look to r. R is a variable that they all share. However, there's 1 r here, 2 here, and 1 here. So we will start off by writing the shared variable of r. Next, we can look at t. Or next, we can look at s, I'm sorry. The first monomial has 1s. The second has s cubed. However, there is no s in the third monomial, so s would not be a shared factor. Last but not least, let's look at t. The only shared factor would be t squared, because t squared is here, t cubed is here, t to the 5th is here. So the one that they share is t squared. So rt squared would be your greatest common factor of the monomial. I'm going to let you try number 4. Again, this is new information, so if you have any questions, please don't hesitate to ask your teacher. All right, these review problems are simply finding the product, which means an answer to a multiplication problem. When you multiply fractions, remember that you multiply your numerators and then multiply your denominators. If you have a whole number by itself, to turn it into a fraction, you simply put it over 1. So this first one would be 20 over 1 times 3 over 10, which equals, if we multiply our numerators, 60, and then multiply our denominators, 60 over 10. 60 divided by 10 does equal 6. Another way to do this would be to cancel before we multiply. So again, we would set it up as 20 over 1 times 3 over 10. We can simplify by dividing both 20 and 10 by 10. 20 would then turn into 2, 10 would turn into 1, which then we multiply 2 times 3 is 6 over 1. So we get the same answer. I'm going to let you try number 2, and I'm going to jump to number 3. So we have 5/12 times 36 over 1. I'm going to simplify before I multiply. I'm going to divide both 12 and 36 by 3. So 12 turns into a 1, 36 turns into a 3. When I multiply across, I get 15 over 1, so our answer is 15. The last set of review problems for this section is just doing the prime factorization of the following numbers. So let's start with 125. That can be broken down into 25 and 5. Again, 25 can be broken down into 5 and 5. 5 is a prime number and cannot be broken down further. So your prime factorization here is 5 cubed. 70 can be broken down into 7 and 10. 10 can be broken down into 2 and 5. All of those are prime numbers, so we stop there and cannot add any more branches. So your prime factorization is 7 times 2 times 5. I'm going to leave the last 2 for you to try. Again, use those factor trees to do the prime factorization. If you're not sure, you could go back and watch the section 1 video and look at those notes, or always ask your teacher.